Hello and welcome to today's webinar, to automate or not to automate cloud cost optimization strategies. This event is produced by Actual Tech Media and presented in partnership with our friends at DoiT. We've got a great event lined up for you today. I mean, this is a hot topic. So many companies out there are moving to the cloud, and cost is a huge concern. So we've got some great cost optimization strategies lined up for you today. Some great ways to save money in the cloud. Before we get started, you should know my name is David Davis of Actual Tech Media, and I'll be serving as the moderator on this event. We want these events to be educational, and we encourage your questions. We even have a best question prize to maybe shake some questions loose. I'll talk about that here in just a moment. You can ask your questions there in the questions pane of your audience console. I also want to encourage you to check out the handouts tab. It's there that you'll find a link to the Cost Conscious Cloud resource. It's a PDF that you can download and check out for additional information after the event. And then finally, at the end of the live event today, I'll be announcing the winner of our Amazon $300 gift card prize. If you're watching this on demand, of course, the drawing has already occurred. The prize terms and conditions can be found in the handouts tab. And then, as I mentioned, we also have our best question prize. This is for an additional $50 gift card. This is for the person that asked the best question today on the live event. You must still meet the Actual Tech Media prize terms and conditions. All right, so with that housekeeping out of the way, it's now time to welcome today's expert presenters. Welcome to Craig Lowell, Product Marketing Manager at DoiT, Mehdi, a Staff Cloud Architect, and Yuval, also a Staff Cloud Architect, all from DoiT. It's great to have you on. I'll first hand it off to you, Craig. Take it away.
Everyone, and welcome to this webinar, to automate or not to automate cloud cost optimization strategies. My name is Craig. I'm a product marketing manager here at DoiT, and I'm joined today by two amazing experts on our cloud architect team, Yuval and Mehdi, who will be going through some of the ways that you can manually control your cloud costs and what actually goes into those management strategies. We'll start today with a brief overview of the world of cloud compute and what it means for your monthly bill. Then Yuval and Mehdi will cover compute commitment management and spot instances before we dive into some of the ways that DoiT helps automate those processes. So the reason that we're all here today is to talk about cloud compute and how you can improve your cost optimization techniques around purchasing that compute. Across the hundreds of cloud customers that DoiT works with, we typically see compute taking up somewhere between 50 to 80% of their overall cloud bill. And sometimes, honestly, it's even higher than that. So when it comes to managing costs, this is the biggest thing that you can do to lower your overall spend. However, managing those costs can be very challenging. This is something that Yuval will be diving into in a moment. But as an overview, the cloud providers like AWS and Google Cloud offer discounts based on long-term commitments in either 1 or 3 year terms. But to take advantage of these, you have to first forecast what you know or what you expect that you'll use over that time frame, and then take the risk of committing to those machine types and at that volume. These commitments can also be owned across multiple teams within your organization, which makes the management challenge even greater for whoever is holding those purse strings. And so with that, I will turn things over to Yuval to talk a bit more about how companies do this.
Thanks, Craig. So I want to talk a little bit about compute commitments, because as Craig said, that's the avenue where you can save a lot of money on your cloud build. Talking about forecasting commitments, or maybe about what are the ways you can save money. So the few basic ways to save on compute, first of all, you can run nothing, which of course you pay nothing, but also nothing happens, which is not very useful for you. But the next best thing is to do autoscaling, or shutting down machines when you don't need them. So for example, if you have a Kubernetes cluster that uses compute, if you set up the autoscaling of the Kubernetes cluster in the right way, then when workloads are used less, then you need less nodes. Kubernetes cluster automatically autoscales down, and then you pay less for your compute. The other avenue for doing that is using spot instances, and that would give you up to 91% of savings, but usually you need to do some re-architecting, and I think Mehdi will talk about that later. And as Craig alluded at the beginning, the simple way, and I mean simple in a way that doesn't, you do not need to do any technical changes, is to commit for the usage that you're already using, and Craig will talk about that later. One of the challenges is if you want to commit, so it's a very easy path to take because no technical changes is done. This is just like a business switch that you can flip to get cheaper compute, but you need to know how much should I commit for, because usually commitments in the different clouds, you get higher discount as you become more when you know exactly what you want to commit for. So for example, a specific region or a specific machine type. There are now also commitments that are a bit more general, but then you get less savings. And managing, like, figure out what is the baseline of commitment, managing the start and end of every specific commitment, when you started the commit and when it ends, it's not an easy task. And I have an example here that just shows, apart from a spreadsheet that we manually help our customers in managing all of the commitments across 2 clouds, and you can see by the size of the spreadsheet that it's not an easy task. And we have a couple of customers that have dedicated people in the organization that all they do is manage their commitments on multiple clouds. These are some of the things that people that are in charge of managing commitments need to keep in their head. That's the complexity. So for example, one of the things that you need to think about is the proportion of how much on-demand versus 3-year versus 1-year commitment should you buy. We used to say that kind of a rule of thumb is that you do about 60% of your commitments for 3 years to capture the big savings, 20% more for 1 year, and then 20% more as just on demand to get some buffer so you don't overcommit. Of course, it depends. If you're a very fast-growing startup, you might be just doing 3-year commits over and over again because you're growing all the time. So this is your buffer. The other things that you have to keep in mind is the regions that you're working at. So some of the more specific commitments, you have to commit to in a specific region and for a specific machine type. So you have to take into account, will you be adding more regions? Will you be moving regions? Another problem is the commits that you purchase, they are staggered. So you might buy something in the beginning of January, and that would be up to the next January, or January 3 years from now, and the next tranche you'll buy is in March, and now you have staggering commitments, and you need to keep all of that in mind. The other thing is that each cloud has some intricacies about how to manage the commitments. So for example, both clouds have dollar-based commitments versus resource-based commitments. So for example, on Google Cloud, for Cloud SQL, for the managed database solution, you can only buy dollar-based commitments. So you commit for $1 amount an hour, and it's region-based. So you could actually add and remove databases, but it needs to be on the same region. On AWS, you have saving plans versus reserve instances. So you need to decide, and I already talked about specificity. So the more specific you are, the higher the savings, the more flexible you get, then it helps you in managing, and you don't have to worry about maybe moving regions or moving machine types, but then you save less. And of course, it doesn't cover if you decide to remove compute. So you can change between, you still need to commit for that specific usage, even if you move it to another usage, but you cannot completely remove usage and get your things back. In AWS, you do have a way where you can resell the commitments that you bought, but that's another stage of another level of complexity that you need to keep in your head. And these people sometimes they have more work to do other than just managing this commitment. So it's a full-time job, and it's very complex. I'd like to pass it on to Mehdi that will talk more about spot instances.
Thanks, Yuval. So now I'm going to talk a little bit more about spot instances. So what are spot instances? Basically, spot instances are a way of using unexploited instances within AWS. So you get a certain discount by AWS doing so. But on the other hand, the price for that is that your instances that you take with the spot purchase option can be interrupted at any time. So this leads to certain caveats and hopefully certain strategies in order to circumvent that. So let's focus on the main challenges of spot instances. The first one being, I said, reliability. Spot instances are interruptible. Deployed workloads on spot instances can be interrupted at any moment, and they can increase the uncertainty of your task completions. The second caveat is the instance right sizing. Instances in AWS have varying nature. You have memory-based instances, compute-based instances, and it's also the same case for demand. So the odds of an instance being interrupted also depend on its nature. So this all put together also complexify the instance right sizing. The third drawback would be the cost management. So as said, you get a discount, but you'll have to bid in order to request and to get an instance when having a spot instance. So this can be complex to manage, and it will be outside of your core business as a builder. So now that we've seen the challenges, let me go through one avenue of circumventing the spot instance strategy within AWS. So the best avenue to do that is the Autoscaling Group. Autoscaling Group, simply put, is a collection of EC2 instances that behave together with a user order. So this way you can downsize, upsize, and you can scale in, scale out your instances depending on certain behavior. This would be considered as AWS best practice. But let's move on from the theoretical phase, and let's build an auto-scaling group with the spot strategy here. So I'm going to share my AWS console. So here I am. I am brand new to the Ohio region. And the first thing that we want to do is to go to EC2. In the EC2 console, we first need, before activating an auto-scaling group, we would need a launch template. So let's create a launch template together. So let's call it demo template. And here I'm going to use the Amazon Linux MEI. So launch template are basically templates for launching further EC2 instances. It's as simple as that. So here, I recommend you to, in order to log in successfully, to have a key pair in order to do that. So let's first create a key pair in order to connect to the instances when it's launched. And then this is it. So in advanced details, you might encounter this option. So this request spot instances, you don't want to click it already because it would be useless for our purposes, which are the autoscaling group. So let's create the launch template here. It has been created, success. So right now, back to our EC2 tab, we are going back to the autoscaling groups. Let's create an autoscaling group, daemon template. And here we are going to select the template that we just created. Next. And here we would like to select at least 2 availabilities here. 2 availability zone. This is considered one best practice for handling spot instances. So here in the instance type requirements, you can either choose a maximum and minimum of vCPUs and memories, or you can manually add instance type. Again, here for managing spot instances, a best practice is to choose your instance type. So you have lots of instance type. Let's choose a memory-based instance type, R5. And let's have a size flexible generation type here. So I'm going to add only a couple of them. So we do have four type of instances. And now the most interesting option in the autoscaling group is that we can go from 100% on demand to 100% spot. And this is the main characteristic in order to proactively use autoscaling group with spot instances. So here we can have we have to choose the allocation strategies in order for your allocation, your autoscaling group to allocate the spot instances accordingly. You have either price capacity optimized or capacity optimized. It depends on the capacity that you demand. So we stick to the capacity demand, and here the capacity rebalance, it would be verified as checked, because when there's a rebalance notification that is sent to an instance, the autoscaling group will automatically replace the instances. So the next is configurations, additional ones. So you also want to enable metrics within CloudWatch in order to have an aggregated view of your logs. And here is the minimum and maximum capacity for your workloads. So let's say we want 3, minimum 1, and maximum 5. Okay. And yeah, another best practice is to send notification. So we are going to use the SNS service in order to send notification whenever an event occurs on the EC2 instances we are creating. So the SNS topic here, I add my email as a recipient from this topic, and it will send a mail for all these event types. Okay, and final thing is to add tag for each instance. Demo instance here. And that's it. We have our instances updating. We have a desired capacity, a minimum, a maximum, but we'll get a notification when event occur. What happens when you want to react on this event. You want to be proactive on this. Right now, let's go back to our EC2 dashboard. We are already seeing that 2 instances are running. So this is great, but I'm not going to spend my whole life in front of my AWS console, seeing if an instance is terminated or not. And to that regard, we are going to implement a hook in order to manage the fact that an instance is suddenly terminated. So let's go back to the autoscaling group. Let's tick in front of the autoscaling group we just created, and let's click on the tab Instance Management. So here we can see that we have 2 health instances in service, and right now we would like to create a lifecycle hook. So Lifecycle Hook is a way to manage a spot instance when it will be terminated. Let's say you want to upload some logs from your system before the instance is just terminated. AWS just provide a management, a lifecycle management resource that will help you doing exactly that. So here we are going to create a lifecycle hook. We're going to provide the name here, depending on the action you want to implement, either on the launch, on the termination. You just choose, because if it's termination, let's say you want to put some log, to upload some log into S3 before the instance terminates, or on the launch you want to download some packages. So when you implement an instance, a lifecycle hook, you'll have an amount of time dedicated called a wait state in order to implement your action. It's usually between 30 seconds and 300 seconds. So the best practice here is 120. And here you'll have an action to take. So either continue the autoscaling group or you abandon. Let's continue here. And yes, we added a lifecycle transition for termination. Let's add another one for launch. So let's say we put 100 seconds in order to download the package. And of course, when instance launches, it would be a shame to abandon the autoscaling group. So now we have two hooks, one for launching, one for terminating, that can later help us trigger other resources within AWS, such as AWS Lambda, AWS SNS, in order to perform some actions that are related to the instance state. Now that I created our autoscaling group, we need some extra implementation in order to have a good spot instance strategy. So we did it when we created. We enable capacity rebalancing. What's capacity rebalancing? The capacity rebalancing option is the fact that autoscaling group will automatically recreate an instance, a spot instance, when this one is terminated. This way, you'll ensure your desired capacity of EC2 instances with Spot. The second strategy to consider is rather a technical one. It's dynamic scaling policies. So it's based on technical metrics such as memory utilization, CPU utilization, GPU utilization, and it scales in or scales out based on several thresholds you configure for your autoscaling group. There's another option which is considered best practice, which is called failover to on demand. So this is basically when you cannot request Spot instances anymore due to whatever reason, you fall back to an on-demand instance, and this way you'll ensure service continuity. And the final item to consider here is the warm pool instance. So basically, it would prepare and create some pools that are ready to use whenever that would be they would be needed. So the main thing here, the main keyword for the Spot instance strategy is to be flexible. So to actually know how to handle termination, know how to handle the launches, and to think about multiple availability zones, multiple instance types, and to have the failover option at hand when we need it. Now that we have recapped Spot instances strategy, I'm going to send you back to Craig that will show you an amazing way to circumvent the caveats.
Thank you so much, Mehdi and Yuval, for that showcase of how to set up a commitments management strategy as well as a Spot instance strategy. So what I'd like to talk about now, now that these guys have shown us the level of complexity and all the management challenges that go into creating and then operating these different types of strategies, I'd like to talk a bit about how DoiT solves these problems for our customers through automation. So we're going to start with DoiT Flexsave, which relates to the commitment strategy that Yuval talked about. So Flexsave is a fully automated SaaS solution created by DoiT that is available at no additional charge to our customers. Now, given what Yuval was talking about with all of the management challenges that go into forecasting and then actually managing those commitments, so making sure that you're hitting your target goals, making sure that you can that you're not going over your commitment allocation and getting hit with overage fees, or even getting hit with under usage fees if you haven't actually fulfilled that commitment. There's a lot that goes into monitoring those commitments across your different teams. So Flexsave provides a fully automated solution to really simplify that process and make sure that you get that commitment discount. It does this by providing a 1-year commitment discount on eligible workloads, and it does that without having to actually sign a compute commitment. So you don't have to go through all of the forecasting and the risk that comes with committing to 1 or 3 years. And like our other products, this Flexsave is available for both AWS and Google Cloud, because a lot of our customers are multi-cloud or exploring multi-cloud or hybrid cloud options. So it's very important that we are able to cover workloads on both AWS and GCP. So how Flexsave works is it is a machine learning solution. So it's running in the background. Once you have set it up, which typically takes 5 to 10 minutes, just to it's very easy. It doesn't require any code changes or any downtime to your environment. Once it is up and running, it is continuously analyzing your compute workloads and determining which workloads you have that are not covered by existing discounts. So in the case of Google users, this would be committed use discounts or flexible committed use discounts. And in AWS, it would be either through savings plans, reserved instances, or EDPs. So anything that is not already receiving specialized pricing will be detected by Flexsave, and then it automatically applies a discount to those on-demand workloads to close that coverage gap. So as you see in this graph here, many of our customers will use commitment discounts for maybe 30% of their workloads and leave the rest to on-demand pricing. Whereas once Flexsave is deployed, those on-demand workloads will also receive the commitment pricing, and it can drastically reduce your overall compute spend. So again, the benefits here are that there are no more compute commitments. You can let Flexsave actually cover all of your compute workloads, and you can do so without any management overhead that you've all talked about, that complicated spreadsheet that requires all the different commitments across all the different teams. You can wipe all of that away and let Flexsave handle all of it automatically. And like other offerings within DoiT, there is no cost to use these tools, which is a real game changer for many of our customers. So our Flexsave customers have been saving quite a bit. This is just showing the second half of 2022, but they've saved over $5.5 million last month alone, and nearly 25 million saved since June. And that will probably be over 30 million by the time we reach the end of 2022. So now that we've covered Flexsave, I want to move a bit into spot scaling to go through all of the different complexity and management challenges that Mehdi walked us through. So spot scaling leverages EC2 spot instances, and that can give you up to 80% savings compared to the regular on-demand instances. So with spot scaling, you can identify where and how to save up to 80% without changing or re-architecting any of your applications. It provides insights, guidance, and automation as well, just like Flexsave, across your cloud infrastructure to really better understand and optimize your cloud spend. So it does this by recommending best practice configurations, and then has additional features that make the process much less complicated than it is if you try to adopt spot instances yourself. So the keys here are that, like Flexsave, you can remove this management challenge and get back to focusing on your core business. Spot scaling is also reliable and safe because it works with AWS native autoscaling groups, and it follows best practices, and it supports that fallback to on-demand feature that Mehdi talked about as well, so that when there's no spot capacity available in the market, you can return to your default state and not have to worry about any downtime. We also pass 100% of these savings from spot discounts onto our customers. So we do not take a percentage. Again, like our other tools, it is free to use as a DoiT resold customer. And you can also easily check potential savings for each of your ASGs, your auto-scaling groups, and also the savings, the savings recommendations from spot scaling. And like Flexsave, you can also get up and running in less than 5 minutes. It just requires a few clicks, and it works entirely within the AWS management console that Mehdi has taken us through. So there's no vendor lock-in as well. So let's jump into a little bit of details on how this works. So a lot of workloads can benefit from spot scaling. Again, it leverages those auto scaling groups to drive efficiency, and it does this without sacrificing any reliability. So you may already be using auto scaling groups, and even if you don't know it, there are many AWS products like EKS that use ASGs behind the scenes. So you are likely already using auto scaling groups, and even if you're not, it's very easy to do. To set these up with the help of our customer reliability team. As you already saw Mehdi walk us through, you can have an expert like that help you out to create these. So again, AWS auto-scaling groups monitor your applications and automatically adjust that capacity to maintain that steady, predictable performance that you want to find. And you see some of the most used scenarios here. Within the AWS environment that spot scaling is often most useful for. So what it does is it automatically scales those auto scaling groups up and down as needed. You have your minimum size and your desired capacity, but you can also increase them with spot instances and then scale back to your default state when they are no longer needed. Some typical savings that we see from here, and this is a typical AWS cluster that a customer may be running. So in this case, it's an application cluster running on 50 M5 extra large instances, which they may not all get spot scaling discounts, but in this case, we're factoring out maybe 40 of those 50 instances will get the spot scaling discount, which is just over 79%. And the remaining 10 will be running on regular on-demand prices. So when all is said and done, that comes out to an overall savings rate of about 63%. And extrapolate that over the course of the year, and you're talking about over $50,000 in savings just for this application cluster alone. So that's all we have today, and thank you so much for your time.
All right. Excellent webinar. Really cool tool. I love the demonstration. Thank you so much for taking time to demo this for us. I love to see products in action. I know the audience loved that as well, and that generated a whole lot of questions. So we do appreciate all your questions here on the event. I'm afraid we're running out of time to answer those questions live. We'll have to get back to all the folks who ask questions electronically. We do appreciate those. Don't forget about the handouts tab there. It's there where you'll find a link to the Cost Conscious Cloud PDF resource. You can download that right now just by clicking on it and check it out after the event. I do want to now announce the winner of our Amazon $300 gift card prize. This is going out to Rochelle Barmarsh from Ohio. Congratulations, Rochelle Barmarsh from Ohio. We'll also be reaching out to our best question prize winner as well. Thank you to everyone who joined us on the webinar today. Make sure that you go check out the handouts tab, get that resource. This is an easy way to get it. And of course, go visit the DoiT website for more information on how to get your cloud cost under control. Have a great day, and we'll see you next time. Bye-bye.